Hi, friends. Have you been wondering about machine learning? There's been a lot of buzz around it, but you're not really sure what it is? Well, strap your seatbelts on because over the next few minutes, I'm going to try to reveal the mysteries of machine learning and its practical applications in your daily work life. So, you ready to go? Okay. Before we get started, to get the most out of this session, I have 3 tips for you. So the first one is, take notes so you can look back on those notes. And then I want you to try some samples. You're going to see a QR code that pops up on your screen. You can open your camera app on your smartphone and just point your camera at the code, and a little banner will appear that you can tap on to access the different resources I'm going to share. The last is to ask questions. So if you're not sure about something or not sure about an application or you just want to debate, write down your questions and we'll be able to get to those at the end. So let's start with what's the difference between AI and ML? Like I really pondered like how can I really start this session for you guys in order to deliver the most value? And I think we need to start by defining what the difference is between these two. So, artificial intelligence is the larger system or the larger construct, and machine learning, as well as deep learning and neural networks that you may have heard of, are part of the entire artificial intelligence ecosystem. So, think of artificial intelligence as a car, right? The shell of the car, and machine learning is the motor, the engine, the thing that makes that car function. So without machine learning, artificial intelligence is just another, clunky item hanging around that you probably left in the side of the room. With machine learning is what powers that AI because it needs data. AI needs data in order to function properly. So they are closely related. They're like, your heart and your body. You need your heart for your body to work. So, I also like to label machine learning as just a fancy labeling machine. So, I think in order to simplify things for you, I think this is a really simple way of putting it. Think of machine learning as just, a labeling machine. Super fancy one that requires a lot of processing power. So what are the building blocks, right? So I'm going to rush through some of this because I really want to get to like the examples that I have for you to help you really build some mental models and get an understanding of what machine learning is. So there are 3 components to machine learning. The first component is data. So you need data in order for your machine learning to be able to do anything. Without data, again, it's just like a broken down car sitting in a lot. Data is the gas that makes your machine learning engine go. And with data, this is where you play a very pivotal part because you should be collecting data that's meaningful. And that data and the quality of that data impacts the output of your machine learning model. So you're not going to be building a machine learning model because we need to leave that to data scientists and machine learning engineers who are specialized in software development, know programming languages in and out, and have the skills and knowledge to be able to create these architectures and support them. Because there's also a lot of impacts of computing that go in there and privacy and all that other good stuff. The second component is features. So features are variables, and variables are things that we can use to extract additional interesting information from that data. And finally, it's algorithms. So an algorithm, you may have heard about algorithms. Algorithms are just rules that we give to a computer to help them complete a task. So machine learning is basically, in its simplest form, the ability to provide a set of rules to a machine to complete a task. So machines cannot just they can't program themselves. They have to be programmed. And so algorithms are a way that machines are programmed. Okay, so how does machine learning work? Let's go into this. There's two types of machine learning. We can categorize them as there's supervised and unsupervised. So supervised machine learning, and I hope this sticks with you. So supervised machine learning means that it needs a teacher. It needs someone to tell it what it's looking at. And so the what is explicitly labeled data. So here we can see on this chart, I have age and height. So my data has an input, which is age, and an output, which is height. And this machine learning model requires both an input and output, and it must be explicitly labeled, meaning age, height, right? So from this data now, we can have the machine learning model predict the height of an 8-year-old. If we were to do this kind of mathematical stunt here, it would take us a long time to really figure that out. Machine learning models can do this within microseconds, where we would have to pull out pen and paper and do some long division and put in our long division algorithms and probably add some algebra in there and probably some trig and God knows what else to be able to do this. But a machine learning model can just do it just like that. So this is what a supervised machine learning model is. An unsupervised machine learning model means there's no teacher. We're not giving it any information. We're just throwing this poor machine learning model into a lake of data, into a data lake, which is just a glob of different types of data. And this machine learning model needs to train itself to be able to make associations between that data. And so let me give you an example here. So let's say someone who buys groceries. The machine learning model may make the inference or the association that that person may be interested in cooking also because, they were interested in groceries. See, someone's interested in a computer, the machine learning model may say, hey, you're interested in computers. You might also be interested in a desk. And it might not be wrong, right? But it also may be completely wrong, because just because someone buys groceries doesn't mean they want to cook. It may just mean they want to survive and can't cook at all. So machine learning models, this is how it works. So you have your supervised, unsupervised. One is labeled data. This is unlabeled data. So we're not telling you what type of data this is. It needs to be able to categorize those data pieces by itself. So think of it, we're throwing a machine learning model into a data lake where it must learn how to swim. And we're not telling it how to swim, so it needs to figure that out. Okay, so that's a lot. Let's look at personalizations and predictions to really make sense of everything that I just shared with you. So we're going to play a game. We're going to play a game of rock, paper, scissors. And I don't know why I always get this title wrong. I usually want to call it rock, paper, scissors, hands, or I don't know what else. But we're going to play a game of rock, paper, scissors. You can scan the QR code. So take your phones out and just point your camera at the QR code and it'll read it and it'll launch a site. Um, just follow along right now so you can see my example. And then once I'm done at the end of the session, I recommend you look at it. So here we are on the site, and this site was actually created by a Googler. It uses TensorFlow, which is a service that allows you to train a machine learning model. They provided us with a data set, and we're going to use that data set to actually train an actual model. So we're going to start here on the first step to load and show examples. And we're just going to be doing button clicking because the engine is working in the background. And if you scan the QR code, you'll be able to visit this site and explore a little bit more. So right now our data set is loaded and you can see it's a bunch of gnarly hands. These are zombie hands. There's different skin tones, different versions of scissors, rock and paper. Some of the paper may look like rock, so it's hard to tell on some of these. These are definitely cheater hands because they're using 3 fingers for scissors, but we'll let that pass for this. So now that we have our data set loaded, we're going to create a simple model. We're not going to do an advanced model because this is a lot more complex and will take more time than I have today for this session. So let's just click on simple model. And you'll see now that this visor tab appeared, and what it's doing, it's evaluating the data that has been input into it to begin to make a decision as to whether it's trainable or not. Can it use the data the way it is? So it looks like it can. And so now what we're going to do is we're going to look at the untrained model. So this is before we do any kind of training, and we'll see that it's pretty bad at making predictions. As I mentioned, remember we said that machine learning is just a big fancy labeling machine. And here we can see that it did a pretty bad job of labeling. So when it was rock, it said it was scissors. When it was paper, it was scissors. And when it was scissors, it said it was scissors. So it just thought everything was scissor. Just like, people who think that everything's a nail when they have a hammer, that kind of thing. So this is an untrained model. And what we're going to do now is we're going to actually train the model. You'll see that there's 2,100 labeled items. So we are working with labeled items. So this makes this a supervised machine learning model. Okay, so let's click train. And while this is going, this is a great way for me to show you visually what a lot of that information was I gave you around supervised, unsupervised, and how to train a model and data and all this other stuff. So this is just putting it into a nice little package for us to display. Okay, so now this is the model's actually being trained, and here you'll see we have on batch and on epoch. So on batch, it's going through each individual image, and this is accuracy, and this is loss. So accuracy is how often is it able to tell that an image is what it is correctly, right, based on the label. And here it's basically how many times did it miss. And so we want to see the loss go down, and we want the accuracy to go up. This on epoch also, similar to above, what it's doing is also validating the accuracy. So we want these to follow a similar pattern to this on batch. And we'll give it a few seconds to complete. And we see that we're starting to get a pretty good accuracy rate here. I think we're at like 90, we're at 96% on the on the batch, and we're at 98% on the 96% on the epoch. And this is getting better and better, and we see that it's learning. So this is how we can tell that a machine is learning. I wish we had this for our learners too. And this speed, right? That would be fun. So right now we're still at 96%. Our loss rate is going down. We're at like 7%, 97%. So we're doing really good. So it looks like it's maybe done training itself. So now let's look at the model after it was trained. And so we're going to go here. This is a confusion matrix if I didn't mention this before. So confusion matrix just shows like, how confused are you? How often? So now we can see that with rock, it was really spot on every single time. It never thought it was anything else. With paper, 10 times it thought it was something else, but 139 times it knew it was paper. And then with scissors, it always knew it was scissors. So this is pretty good. So the machine has been trained to be able to identify these labeled graphics, right? Labeled data, so it can make predictions as to what it is. So right here, this is just a simplified way of showing you how what goes on in the background where you're training a machine learning model. In this tool, you can also use it. Once you do this, you can use your camera to see if it can identify when you're doing rock, paper, or scissors. You would just launch your webcam. I recommend that you do it in a space with no clutter, where the only thing you have is like a white wall, and test it out. This is a lot of fun to actually do. So this is our training a machine learning model. Let's get back to the rest of our content because I have a lot to cover with you. All right, our next tool that we're going to look at is Apply Magic Sauce. So go ahead and scan that QR code when you're ready, and then I'm going to show you my example. So this app, Apply Magic Sauce, is a lot of fun. It uses your personal social media data to figure out your psychological profile. So I'm going to go down here and scroll. And you can use your Facebook data, your Twitter data, your LinkedIn data. You have a lot of data that you've probably have gathered over the years. All of this data is yours. You can use the tutorials at the bottom to figure out how to download your Facebook data, your Twitter data, and your LinkedIn data. And you can upload that data here into Apply Magic Sauce. This is not a commercial product. This is more of an academia product. And so when you connect those data points into this app, it just does an analysis for you. So I'm going to connect to my Twitter. I'm not going to connect everything else. I'm just going to do Twitter for right now. And then I would have to get my Facebook and my LinkedIn data. But now I'm going to have it make a prediction because you see that these lines right here say that it's feeding in my data. It's looking at 381 tweets. I have a lot more tweets than that. And it's going to feed out this prediction. So let's click on Make Prediction here. And let's see my results. So my profile, my psychological profile, is that of a 26-year-old male, which is par for course for me, right? And then my big 5 personality traits are here: strongly liberal, strongly easily stressed and emotional. It's interesting how this data changes when you import your other data, your LinkedIn and your Facebook. I've done this in the past, and it provides you some really interesting insights. So this here is a quick way where you can play with your own big data, because your social media data is big data. It's data that you've collected over the years, and you probably have petabytes of data. So petabytes are like a huge amount, like billions amounts of data. So let's move on to the next one. Now, you may have seen from my example that there was some bias injected in there, right? I was classified as a 26-year-old male. This is the problem with machine learning. And it's not so much the fault of the machine, but the fault of the data that is being injected into these machines. So, right now, machine learning is being used for law enforcement. It's also being used by some HR organizations around pay, and it creates a huge gap in issues. So the first example is here between James and Robert. You can see that James was classified as low risk and Robert as high risk. And this is because there was bias in that system. So even though James had more offenses, Robert was seen as a higher threat because of his skin color and probably his age also, or what his appeared age. As far as pay and equity discriminations, when you're loading historical pay data into a machine learning system, it's going to look at the fact that men are historically paid more than women, right? So it's always going to bring in a lower offer for women, because historically that is how we're paid. And so machine learning scientists have the moral obligation to ensure that that data that's being injected is corrected or normalized, that some kind of labels are put in there to ensure that if they're using machine learning models for this pay equity, or even for promotions or whatever it may be used for, that it's being equitable. Practical applications of machine learning. Now, this is things that you can use. Now, remember, I shared at the beginning that artificial intelligence and machine learning are best buds. So they're always together. You cannot have AI without machine learning, so they're like this. Okay, so let's get started. My first tool that I'm going to introduce to you is a transcription tool called Otter AI. Now we're on the Otter AI platform, and you can register with a free account on Otter AI just to try it out. What this is actually a transcription service, and they've added some additional transcription services that map to other programs. For example, they have now introduced transcription for Zoom, which is a lot of fun if you want to try that out. But I'm going to show you how this works. So you can either import a file like a video or a podcast, or you can record. And for this demo, we're just going to record. And you'll see that we can name the note, and it begins to actually transcribe what is being spoken. As I speak, it's picking up my mic down here. I can pause the transcription. I can make some cuts and edits. This is just going to copy it completely. You notice also that there is timestamping on here, and this is so you can create SRT files, which are used for closed captioning. So with a premium account, you can export this file as an SRT file. So let's stop here. Just click on the note to open it. And here you'll notice that we have this export text. Here I can export this as a text file, which is the default, but I can also export it as an SRT file, and this is the closed captioning format. So if you're trying to add transcription to a video, this is one way that you can do it. So let's go back to explore more applications. This next service, eLink.io or elink.io, can be used to create portfolios, newsletters, and even job aids. You can get really creative. So be sure to scan that QR code. So here we are on the elink.io site, and this is a content curation platform. So what you can do with this platform is you can create a portfolio, you can create a job aid, you can create different types of documentation that then you can share with other people. You can export it as an HTML, so there's different formats. And as you can see here, I have a starter page already with some content, and there's some videos in here. I'm going to add additional links. So you can just come in here and gather your links and just easily paste them in here. I just took this from a search that I did on my name. And the content then appears here, and you can move it around, you can rearrange it, you can select a different layout for your page. So it could be something like this. So you have different options in here for your layouts. And as I mentioned, once you publish, I'm going to save it. And when you publish it, you will have the ability to get a link. It's an HTML file. And this file, you can then convert it into a PDF, but you can share it easily on social media, or you can send it as a standard newsletter. So this is just a quick demo on elink.io. So let's get back to the other platforms. Now, Microsoft Office has some fun AI built into it. In fact, you're going to see how I am using one of those features right now. Okay, so let's look at an AI feature in Microsoft Office. So now I've gone out of presentation mode just so I can show you these two features. So if you've noticed the captions at the bottom of my presentation today, those were done created using Microsoft 360 Online. You do require a subscription for this particular tool to work. But once you have a full subscription, you can go to Slideshow, and you'll see here there's this option to always use subtitles. The subtitles, you can decide where you want those subtitles to appear. And then you can also select the languages. So, I'm speaking in English. I have English selected, but my subtitles could be in Spanish. So let's see how it appears on screen really quick. So let's go into presentation mode. So thank you. This is my presentation for you today. And as you can see, what I'm saying is appearing translated at the bottom of the screen, and it's doing a really good job. So this is a feature that I use with my international clients when I'm having to do presentations, especially virtually, right? This is really helping me to close that gap and ensure that the people attending my sessions are able to have my speech translated for them in their language. So let's go back. The next tool that I'm going to show you that's really cool here in Microsoft Office is this Rehearse Coach. Now, both of these are AI driven, backed by machine learning. So the machine learning is what's going in the background to help translate what I'm saying, my speech, into text. Then there's this Rehearse Coach. When you go into Rehearse Coach, there's this button that appears down here. This is really good for presentations, and I'll just show you. So I'm just going to start talking as if I was starting my presentation with you. We're going to cover a bunch of different topics, and so you'll see that it's giving me feedback in real time at the bottom, and it's really asking me to stop using those filler words like, and like, So it does a really good job. And then once we stop here, let me end my session. It'll give me a score. So it gives me this rehearsal report that will let me see where I need to improve um, my delivery. So there's like a pitch score, a pace, summary, originality, my sensitivity phrases, pace over time, and my fellow words. I use a lot of you knows, and likes. So this is just one of the features that you can use in Microsoft Office. So let's go back to the presentation. So let's go back to our session. So let's go back and evaluate more tools. And that's it. That's all she wrote. So thank you so much for joining me. I hope that you found this session to be insightful, that you learned something new, that you found it extremely useful, and that you have some new tools in your toolbox. And if you have questions, be sure to shoot them my way. So I'm Myra Roldan. And of course, the transcription service did not get it right. You can scan my QR code there and let's connect on LinkedIn.